Now this is a handy little question here, and it brings in, even just this part A here, brings in a whole host of different topics, right? Now straight away you can see it's something to do with functions, and straight away it's something to do with trigonometric functions and graphs, right? As soon as you see tangent, you must be thinking it's something to do with calculus, right? And there's also a bit of trigonometry in here just for good measure. So let's see, we're trying to make associations now in our head, like, because it's not immediately obvious how we're going to do this. What are they talking about here with this angle? But this is the first kind of clue, a tangent. And as soon as you see a tangent in relation to calculus, you're thinking, well, the tangent, find the tangent, you're looking for your first derivative. Okay, that's what helps us get the slope of a tangent. Okay, now the second thing is this, the angle. Okay, now that this is a kind of a less well-known rule, right? That the tan of the angle, that's this angle that they're talking about, is equal to the slope of the line. Right? Now, if you're not familiar with that, this is what we're talking about. If you want to find that angle there, or that angle there, they're the same angle, then if you were to find the slope of the angle of this line, it would be the rise over the run. And if you were to find the tan of this angle, well, that would be the opposite over the adjacent, which is the exact same thing. So the opposite over the adjacent is the same as the rise over the run, so therefore the tan of the angle is the same as the slope. Now, even if you're not 100% sure of following that, as long as you kind of remember this kind of formula, it's always a good one. It's a helpful one that helps you solve a few problems every now and then. So let's get going. So first of all, we're going to find the slope of this of the tangent at this point. I know it doesn't say it there, but that'll help us get our answer. So we have our function. To get the slope, we get the derivative, right? Cos goes to sine, 2x. The angle stays the same, and we multiply by the derivative of the angle, right? Cos goes to minus sine, sorry. And now we just sub in our value for x, right? Now this is all in radians. If you type all of that into your calculator, you'll get your answer. But you should also be able to use your log tables for this. Sine of 2 pi over 3, I think, is root 3 over 2. The 2's underneath the line will cancel, so we're just left with minus root 3, right? But as I said, your calculator will do all that for you. Okay, so now we know the slope of the tangent to the function at this point, but we now want the angle, right? And as long as you just remember this formula now, so far we know that the slope of the tangent when x is equal to that is root 3. That should be minus root 3 there, sorry. And if we want to find the angle now, we just use this formula. Okay, so tan theta is equal to minus root 3. The inverse tan of this will give us our value for theta. Now just watch out for this, right? That on your calculator, that'll say minus pi over 3. Right, now that's not really an angle, right? So the angle in this case is 2 pi over 3, right? So you need a good knowledge of the unit circle there to figure out why that is. And if you want to put it to degrees, it comes to 120 degrees. Now, this then is a slightly easier question, okay? Because as soon as you see this average value, should be jumping off the pages here, that this is integration, right? And it's this formula. Okay, and even if you're not even, like 90% of people won't even understand what this means, what your solution means, which is fine as long as you know what the formula is. The understanding usually comes later. So we're going to take our function, integrate it. Don't be turned off by the pi over 4 and all this stuff. It should work exactly the same. These are two definite integrals, and it's 1 over that minus that. Simplify that down. Now look, just watch that there, right? 1 over pi over 4 is the same as 4 over pi, right? It's kind of the inverse of each other. Cos goes to sine when you integrate it. 2x stays as 2x, but you divide by the derivative of the angle. And then we sub in pi over 4. Look, just leave that 4 over pi outside it there. Right? Sub in pi over 4, sub in 0, subtract 1 from the other, and we get this. And all of that works out then as 2 over pi. Now, let's have a quick look at what our solutions actually mean. Right? So we got 120 degrees for this, and we got 2 over pi for this. So if we plot this function, cos 2x, we know everybody should be familiar with the cos functions, right? And because it's 2x, it means that the period is halved, okay? So we wanted the angle at pi over 3. Now, pi over 3 is around here somewhere. Okay, that's pi over 4, that's pi over 2, so it's halfway between them there. So if we want the angle at this point, of the tangent at this point, then it's 120 degrees. And they're on about this angle here, look. Okay, so that angle there is 120 degrees. Okay, so it's an interesting just to visualize what it looks like. And finally, what does this mean? Well, we want the average value between here and here, okay, is 2 pi. Right, so 2 pi is roughly about 0.6, kind of that kind of area. So that's what they're talking about there. And again, that one is kind of hard to visualize what that actually means. Hopefully this one makes a bit of sense. But it's always good to visualize what your answer means in the end.